All right, example 5. Again, we're going to be using logarithmic differentiation to find the derivative of this function, y equals x e to the x. So, this is, upon the first glance, quite peculiar looking, and seems like we have no idea how to do it. Because although we do know how to take the derivative of things like b to the x, where b is a real number, not a variable, and of course this is b to the x natural log of b, we also know how to take the derivative of things like x to the b, where now we've got a variable for the base, but a constant exponent, and this is just good old power rule. But we've never encountered anything where we have basically a variable raised to a variable. We haven't done that yet. So that's sort of what's going on here, because if we were to use the chain rule, we would have to know how to differentiate this, and then if we know how to differentiate that, then we could definitely just use the chain rule on that, but we don't know that one. So in this case, logarithmic differentiation is what provides for us a way to actually calculate this. So first step, take the log of each side. Second step is to simplify anything that can be simplified. In this case, I can pull the exponent on this x out, so this whole e to the x can come out front. So this would be e to the x times the natural log of x. Step 3 is to then differentiate each side. So left-hand side, again, 1 over y dy dx. This is just implicit differentiation. It's the chain rule. Here we have a product rule, so derivative of the first times the second left alone, plus the first left alone times derivative of the second times 1 over x. And then dy dx is, of course, x e to the x. Excuse me. It's y. Let's do this in 2 steps. So step 1 would be to multiply this y up and over to the right. So then we have this. And I guess I'll just write it like this. But then the last step would be, since we actually do know what y is equal to x e to the x, we can just replace this y with an x e to the x. And that's the derivative.